Hi there, Math 8 students. Hope things are going well for you guys. I just want to encourage you guys to keep up the hard work you've been doing. So this here is going to be a recording to help prepare you guys for our next test, which is going to be on February the 22nd. And it's going to cover lessons, material from lessons, just a sec, I believe it's 15 to 23. Yep, that's right. Lessons 15 to 23. And yeah, so we'll get started in just a sec. I don't know about you guys, but I'm excited about the fact that we've got one of the coldest months out of the way, January, and February is usually one of the other ones. And we're getting along in February, so before long we're going to have spring, and I think that's awesome. Another thing I'm excited about is tomorrow I'm going to an Oilers game against Chicago. They haven't won for a while, but hopefully they pull this one off. So, all right, so hope you guys are doing really well again, and let's kick this off then. So the first page here, it talks about, we're going to talk about ratio and rate. And remember that a ratio is a comparison between two different things. So for instance, we have 3 blue balls here, 2 red balls here. And so we would say the ratio is 3 blue balls to 2 red balls. And when you write that as a ratio in math, you write it as 3 to 2. And you can see that the 3 here just comes down to the 3 here, and the 2 here becomes the number 2. So 3 to 2 is the ratio of blue balls to red balls. Now, it's important to notice as well that if we were talking about the ratio of red balls to blue balls, if we phrase it that way, where we say red first and then blue, then the ratio is 2 to 3. Okay, that's the ratio of red balls to blue balls. So again, really important which word you say first. All right, so check this picture out. This guy's a pitcher, and he's making juice in a really interesting way, throwing it into an airplane engine. Bet you've never seen it made that way. So anyways, I just chose that picture because we're talking about a question that has to do with making juice. So the question here says, Mr. K needed to make some juice for the next activity day. The can of juice concentrate calls for 4 full parts of water to 1 part of concentrate. So that's the juice. So the question says, show this in a ratio of water to concentrate. So the first thing we always want to do is pull out the information and write it in a sentence. So the sentence we would write is 4 parts water to 1 part concentrate. As soon as you've got the sentence, then you can write the ratio, because under the 4 parts water, we just write the number 4. Under the 1 part concentrate, we write the number 1. And the word 2 really means the same thing as this colon. So it means 4 to 1. That's the ratio. It's 4 to 1. Okay, so that's not too bad, eh? So moving on to the next question. This question says, so 1b says, if you needed to triple your batch size, what would the new ratio be in non-reduced terms? Okay, so we don't have to reduce it if we're going to triple our batch size. So the question I have for you to think about here, what do you think we're going to have to do to both numbers in the ratio, since the question talks about tripling the batch size? So what kind of math do you think we're going to have to do that? Okay, well, what we're going to have to do is when you triple a number, that's times 3, right? So we're going to multiply the 4 times the 3 to get 12, and the 1 times 3 to get 3. So 12 to 3 is the ratio we're going to use if we're going to triple our batch size. Right on. Okay, so now we're looking at finding the missing values in ratios. Now this is actually what you'd call a proportion, because when you have 2 fractions that are equal to one another, that's a proportion. But ratios and proportions are fairly similar. So there's 2 different ways we could find this missing number here, which we're calling x. One way is what we call inspection. That's just by looking at it, right? And so for certain types of questions, you can do that. So here you can see that 9 is 3 times as large as 3, so 36 is having to be 3 times as large as this missing number. So what number times 3 is going to give us 36? Well, that's going to be 12, right? So the missing number is 12. So again, in this situation, you can do it just by looking at it. Okay, so x must be 12. But in other situations, you can't do that. But another way of finding the missing number is by cross-multiplying. In most situations, you're going to have to do that. So what is cross-multiplying again? It's multiplying the top of one fraction by the bottom of the other fraction. And then we also multiply the bottom of this fraction by the top of this fraction. So first we multiply the 9 times the x, and that gives us 9 times x, which is just 9x. Then we multiply the 3 times the 36, and that gives us 108. And so we've created an equation, 9x equals 108. And now we have to solve that equation, and we can find what x is. That's what we're looking for, our missing number. So since we want just x on the left side of the equation, and we have 9 times x, the opposite of 9 times is divided by 9. So we need to divide both sides of the equation by 9. So when we do that, we end up with just x on the left side, and then we divide 108 by 9, and we get 12 on the right side. So x equals 12, and so the missing number, again, is 12. Really important to know how to cross-multiply, because that's something we do throughout this year. Okay, so in this next question here, it says in these ratios, find the missing values of x, y, and z. And it says here that you would need to show work. Okay, so to find missing x, what we always want to do when we're trying to find a missing number, we want to find one fraction that has both numbers on top and bottom. That will help us find one of the missing numbers in a fraction. Okay, so we're going to use 36 and 8. Now, with this one, we can do inspection, because we see that 8 is twice as large as 4, so 36 has to be twice as large as this missing number, so x is going to have to equal 18. Okay, now that we know what x is, we can also go on to find y. Now, if we want to find y, again, we want to use the fraction that has two numbers that are known to help us find y, and it's always best to use the original two numbers that are known, not use this x, because you could have possibly made a mistake here. So we want to use 36 and 8 to help us find y. So what are we going to use to help us find y? We're going to use cross multiplication, right? Top times bottom, bottoms times top. And so to do that, we're going to multiply 8 times y. That's shown here. And then we're multiplying the other top times bottom, and that's 6 times 36. So we get an equation, 8y equals 216. Again, we're going to divide 8 by both sides by 8. And when we do that, we're going to get y on the left and 27 on the right. Okay, so now we know what y is, and we just need to find z. Okay, so I actually filled in what x was and what y is, and so now we just need to find z. So what method do you think we're going to use to find z? Okay, so what I want you to do, now that you've decided which method it's going to be, set this method up on paper, and then I'll give you just a few minutes to do that, and then I'll go to the next screen and you can check your answer. So again, remember at this point you don't need to actually solve it, you just need to set up the method you would use to find z. Okay, so let's check out how you did. So you'd use cross multiplication again, remember, to solve for z. 27 times z equals 6 times 48. We get 27z equals 288. Again, like we were doing before, we're going to divide both sides by 27 to get rid of it. And we're going to end up with z equals 10.67. This time we've got a decimal. Okay, so now we write all the answers we have for x, y, and z. And that's how we would write our answer for this question. Right on. So now at this point we're going to talk about rates. So remember, the word rate is kind of similar to speed. But it doesn't always mean the same kind of speed as a car sort of driving speed. If you're typing at 30 words per minute, that's another type of speed. Here we got another picture of a race car driving along. I don't know if you guys have ever seen a race car race before. I almost saw one before. A friend of mine is a journalist, or studying journalism, and he got me tickets, and I took my son, but my son found it too loud. It was some sort of cars that were really, really loud, so we had to leave. Even with the earplugs, it was still too loud for him. Okay, so next question says, if you can drive 130 kilometers per hour, and then it says, hint, draw this fraction. Okay, so we know that so far. How far would you have traveled after 1 hour and 25 minutes? So round your answer to 2 decimal places. So the first question I have for you guys is, what will you have to do to make sure your units are all the same? So just have a look at the question and see what you're going to have to do so your units are going to be all the same. Okay, what you're going to have to do is you're going to have to change an hour into minutes. Either one way or the other, right? So we're going to change everything into minutes. So we say that 1 hour equals 60 minutes. And so 1 hour and 25 minutes is going to be 85 minutes. Now what we can do is we can solve a proportion to solve this question. Now remember, a proportion is 2 fractions that are equal to one another. And the question says, hint, draw this fraction. And it says right after 130 kilometers per hour. So we need to make a fraction out of 130 kilometers per hour. So since we made an hour into 60 minutes, we're going to make that fraction 130 kilometers per 60 minutes. Now if it's 130 kilometers per 60 minutes, and we're trying to find how far you travel after 1 hour and 25 minutes, since you don't know how far you travel, you're going to make that into x, and you make the amount of time which you do know into 85 minutes. So now you have a proportion, and again, we can solve a proportion by cross-multiplying, right? Before we go on though, let's say this question didn't have a hint in it that said use a fraction. Well, what I often like to do is I like to write the info that we have in a sentence, and that's another way that will help us find a proportion. So let's say you knew the fact that you travel 130 kilometers in 60 minutes. You kind of write those 2 pieces of information together because they go together. And then you say, okay, well then I travel X kilometer in 85 minutes. And that, setting it up that way can help you set it up as a proportion. So if you go on to the next screen, once you see that it's connected this way, that 130 kilometers is connected with 60 minutes, you can put that 130 kilometers over 60 minutes, you put the X over 85, and now you have your proportion set up and you can solve for it. So we know we use cross-multiplying. Okay, so again, see what you get after cross-multiplying. I'll just give you a sec, and then you can check your answer. So just set up the cross-multiplication. Probably won't take too long to write it down. Okay, so it's going to look like this, right? 60 times x equals 130 times 85. 60x equals this amount here. Now we just solve the equation like we've done it before. We divide both sides by 60, and we get this answer here. Now here's where we have to look at the question again to help us. It says we need to round the answer to 2 decimal places. So we look at the 3rd decimal place to help us round, and since it's greater than 5, or rather it's 5 or greater, we round up, so it's 0.17. So 184.17 is how far we're going to travel. All right, cool. Now, it's important to note that a lot of times when we need to find a rate, we have to divide, right? So if you had 120 words per 3 minutes, you would divide the 120 by 3, and that would give you 40 words per minute. And that's what you call a unit rate, right? It's a unit rate because it's based on 1 minute, 1 unit. Okay, so now that we know we have to divide a lot of times to find a rate, let's use that in the next question. So we got a picture of this bunny rabbit here. So question says, if 4 ski lift passes cost 64 buckaroos, okay, in other words dollars, right? What is the rate per one person? So, the question for you guys, what numbers would you divide here to get the unit rate? Okay, well you would have to divide the $64 per 4 people by 4 people, and when we do the division of 64 divided by 4, we're going to get $16 per one person, and that there is a unit rate. $16 per person is a unit rate. So that's all we have to do for this one. Not too bad, eh? Okay, next question. Jason's mom drove 50 kilometers to the city at 70 kilometers per hour. Then she drove back home at a rate of 80 kilometers per hour. What was the difference between the trips? And it says, hint, find the length of time of each trip. So my question for you guys is, what type of math operation, example, addition, subtraction, division, multiplication, would you use to find the difference in time? Okay, when you're trying to find the difference between two things, whether it's temperatures or whatever, what math operation do you use? Well, we're going to use subtraction, right? So we're going to take the time of the longest trip and subtract from it the shortest trip, and that's going to give us the difference in time between the two trips. Right on. Now, if we need to calculate time, what's the formula for time? Well, this might not be given on tests, so you're going to need to know what it is. But you can use the formula for speed. And here's something that's really important. Here's an important way to help you remember the formula for speed. All you need to think of is the sign on a highway. And just think 50 kilometers per hour, right? That sign right there, 50 kilometers per hour, tells you what speed is, because it tells you that speed equals distance divided by time. Okay, so now that we know what the formula for speed is, we can use that to help us find the formula for time. So to do that, we can, since we know how to cross multiply when we have two fractions, we'll just make speed into a fraction by dividing it by 1. So now we have speed over 1 equals distance over time. Now we want to find out what time is, right? So what we do is we cross multiply again. We can multiply 1 times d, and we know that's the same thing as just d. So d equals s times t. Now we want to find what t is, time. So to find what time is, since you have s times time, we do the opposite of s times, which is going to be divided by s. So we divide both sides of the equation by s, and we end up with time on the right side. Time is equal to distance divided by speed. So now we used the formula for speed, which we could remember by just thinking of the sign on a highway, and that helped us to remember or to figure out the formula for time. Okay, so time equals distance over speed. That's what we need to solve this problem. Okay, so going on to the next question, time equals distance over speed. So we're going to use that to find the time of the longest trip. Now that's going to be the first trip because you're going 70 kilometers an hour, a shorter speed, or a smaller speed. A shorter speed is going to be a longer trip, right? Okay, so again, time equals distance divided by speed. The distance given in the question divided by the speed for the longest trip. We do the math and we get 0.71 hours. And we do the same type of math to find the shortest trip, and that's going to be 0.63 hours. Now we use this formula, time of longest trip minus time of shortest trip equals difference in time. We subtract the two numbers and we get this amount. Okay, so that's how we do this one. All right. Question number 6. Numéro 6 in français. Oui, oui. Okay, so this one says, if Sally asks, Sally asks, if 20 plus 5 equals 25 and 30 plus 5 equals 35, then why does 20 to 30, the ratio of 20 to 30, not equal the ratio of 25 to 35? There's a question, eh? I wonder why. Well, to help us with this, let's think about something for a sec. What math operation would we use to change any ratio like 20 to 30 into an equivalent ratio? Okay, think about equivalent ratios. What do we do to them to take one ratio to produce another ratio? What kind of math operation do we use? Well, remember, just like with fractions, if we want to change, say, 1/2 into an equivalent fraction, we multiply both the 1 and 2 by 2, and that gives us 2/4. Or we can go the other way around, take 2/4 and divide both numbers by 2 to get 1/2. So we multiply or divide ratios to get equivalent ratios. So just like if you're taking 8/12, you can divide 4 into both numbers and get 2/3. So 2/3 and 8/12 are equivalent ratios. That's just kind of helping us to get the background info to solve this question. So back to our question. The reason why we can't just add 5 to 20 and 5 to 30 is to get equivalent ratios. We've seen already the only way to produce equivalent ratios is to divide a number, both numbers by the same number, or to multiply both by the same numbers. In this question here, what Sally's trying to do is she's trying to add a number to both the 20 and the 30 to get an equivalent ratio. But we can't do that. We can only multiply or divide. Okay. So here we've got a bunch of different colored balls. I don't know if these are marbles or gumballs or something like that. Anyways, so the question here says Mr. Mac has 9 white balls, 21 black balls, and 24 green balls. Find the ratio of, the first question says black balls to white balls. Okay, so guys, finding ratios is pretty easy really with this kind of question, because all you need to do is first write the ratio as a sentence, and then you write the numbers below the sentence. Now the good thing is in this question we already have the ratio in a sentence, or kind of a phrase anyways, black balls to white balls. So we just write that down or copy it over, black balls to white balls. Now all we need to do is take the info given in the question and find out how many black balls there are. And we see here it says 21 black balls. So under black balls we write 21. Under white balls we write the number that we see in the question, which is 9. So 21 to 9 is the ratio. That's all we need to do to find the ratio. Now if the question said find the simplified ratio, we could simplify 21 to 9. We could see that 3 divides into 21 and 9, and it gives us 7 to 3 as a simplified ratio. But this question actually didn't ask for that. Okay, let's look at the next one. So part 2 of this says, find the ratio of white balls to the total number of balls. Okay, what would that be, the total number of balls? So think about what ratio you would write here. I'll give you just a sec because there is some calculation involved here. What would you write as an answer? Assuming you got your calculator here and you're doing some addition. So what you're needing to do, the white balls we can get right from the question. The total number of balls, we just add up the green, the black, and the white. And here I'm showing how to do that, and you get 54. So 9 white balls to 54 total balls. And again, if you simplified it, it would be 1 to 6. Good stuff. Last question says, find the ratio of black to white to green. So again, under black, we just write the number of black, white the number of white, green the number of green. If you had to simplify it, you would get 7 to 3 to 8. Okay, this picture here kind of throws me back to way back when, in probably the 70s, maybe even 80s, I'm not sure. They had a show called Let's Make a Deal. I'm not sure if it's on TV anymore, but this was kind of an interesting show. People would dress up for this show. They'd dress up in these wacky costumes. And the main idea behind this show is that contestants had to guess whether the prize was behind door number 1, 2, or 3. Normally 2 of these doors would give you a prize, but the third one would give you something called a zonk. Maybe you'd win like this actual animal, like a llama. whatever the case was, you got zonked and you got a really bad prize. Okay, so that's kind of to introduce us to our next question here, because Let's Make a Deal was all about finding out which was the better deal, which store. So which is the better deal, 4 batteries for $5.23 or 15 batteries for $20.55? Well, that's the kind of thing you might have in real life. You're there at a store and you're trying to figure out what the better deal is. Well, what you need to do is you need to divide to find the unit rate. And so you're going to have to divide the cost by the number of batteries. That will give you the unit rate. Once you find the unit rate for this one and for this one, then you compare the left unit rate to the right one to see which is the lowest unit rate. And that's what we want to pay, the lowest amount of money. So when we do the division, we divide 523 by 4, we get $1.31. We do this division here, we get $1.37. So when we compare left and right, we can see that left is the better deal, right? Awesome. Okay, now here's a chance for you guys to try one. So this one involves pens. So try this on a piece of paper. Use your calculator. Use the same steps that we did to find the unit rate and see which one's the better deal. I'll give you a few minutes to do that. Okay, so you can see that when you divide 775 by 27 pens, you get this amount, and the other one you get this amount. So you can see that again, the one on the left is a better deal. And we could say this amount per pen is the unit rate. Good stuff. So we're going to talk about percentages right now. Now, there's two important things that we can remember about percentages anytime we're dealing with questions that have to do with them. Remember, the word percent actually means out of 100 or divided by 100. If you think about cent means 100 in French, so per cent means divide by 100. Of in math always means times. So remember these two important pieces of information. If you ever forget them, put them up on a piece of paper. Remember, keep your notebook. We talk about that a lot. Make yourself a math notebook and keep a good notebook, and that will help you. So if you have a question like this one here, these two pieces of information are going to help you. 40% of 200, 40% is 40 divided by 100, so we put that down. Of means times, so it's 40 divided by 100 times 200. So now all we need to do is do the division and get a decimal, and then we can multiply that decimal times the 200, and we'll get the answer. Okay, great. So again, always remember these two pieces of information. We're going to try a few questions now. So same deal. 25% is 25 divided by 100. Of is times. Now we do the division of 25 over 100. We get 0.25 as a decimal. We multiply the decimal times 400, and we get 100. And it makes sense, too. It's always good to check and say, okay, what is 25% of 400? 25% means the same thing as 1/4, right? And so 1/4 of 400, yeah, it makes sense that it would be 100. Okay, so for the next one, for B, try this on a piece of paper. See if you can use the steps that we just used, and see if you can get the answer for 40% of 800. Okay, so 40% of 800, 40 over 100 times 800, 0.4 times 800, 320. And again, check your answer. 40% kind of sounds close to 50%, right? We know 50% is a half. A half of 800 would be 400. It's a little bit less than a half. Makes sense, the answer, doesn't it? Good stuff. Okay, try the last one. 1% of 200. Okay, so again, 1 over 100 times 200, 0.01 times 200 gives you 2. All right, so let's go to the next one. Next question is going to be a little bit different sort of a question involving percents. So this one says 25 is 50% of what number? So what I want you guys to get used to doing is taking all these math words and changing them into math symbols. Okay, so the way we do that, you can see I put these words in different colors, and so below 25 I write 25. Below is I wrote equals, because is means equals. Okay, below 50% I wrote 50 over 100. We know that percentage is divided by 100. Below of we write times. Below what number we write n. We don't know what n is, so we just put a variable that stands for that number. Okay, so we've changed the sentence here into math, and now we're going to be able to solve that. So I just kind of use this here, this picture, to show you that it's kind of like translating, right, from one language to another, math words into math symbols. Okay, so once we've got this here, that's where we finished off. 50 divided by 100 is 0.5. We write that down. Now 25 is 0.5 times n. 0.5 times n is the same as 0.5n. Now we've got ourselves a really simple equation. Now what are we going to have to do to both sides of this equation to solve for n? Well, we know we're going to have to divide both sides by 0.5. And when we do that, we get n on the left, and we get 50 on the right. Or sorry, 50 on the left, n on the right. Okay, so here was the question. 25 is 50% of what number? The number is 50. And that makes sense, doesn't it? Because think about it this way. 50% is half of, right? So 25 is half of what number? Well, 25 is half of 50, right? So again, it's good to look at the answer and see if it makes sense going back to the original question. Always good to check your answer that way. That's a good thing about math. You can find out a lot of times if you're right. Okay, so here's another one, and I want you guys to take the method that I just showed you and to translate these words into symbols, math symbols, and then I'll show you the answer in just a sec. So for now, you're just writing that out as a math equation. Okay, let's check it out then. So we write 100 equals 25 over 100 times n. 100 equals 0.25n. Now again, we solve for n, we divide both sides by 0.25. I'll let you guys try that out, see what you get for n. Okay, when you divide both sides by 0.25, you should get n equals 400. Again, 100 is 25% or a quarter of what number? 100 is a quarter of 400. Makes sense. Okay, so now we're going to talk about fractions. A little bit of a difference here. We're going to review how to change a fraction like 12 over 64 into three different things. We're going to change that fraction into a fraction in lowest terms, so we're going to reduce it. We're also going to change that fraction into a decimal, and we're going to change that fraction into a percent. So first we're going to change this fraction into a fraction in lowest terms. So what type of number do we need to divide into both the top and the bottom of this fraction if we're going to change it into a fraction in lowest terms? We're going to need to find a number that's the largest possible number, right? We want to find the largest number that divides into both 24 and 64. So let's just say we think that that largest number is 4. And if we can't even think of 4, we might say, okay, I'll start with 2. I'll divide 2 into both 24 and 64. But if we think the largest number is 4, 24 divided by 4 is 6, 64 divided by 4 is 16. So now we got 6 over 16. Is that the fraction reduced to lowest terms? No, because we can still divide 2 into both 6 and 16. When we divide 2 into both, we get 3 over 8. So 3 over 8 is 24 over 64 in lowest terms. Now notice, if we would have known that 8 divides into both 24 and 64 and is the largest number that divides into both, we could have divided 8 into both numbers and we would have got our answer 3/8 right off the bat. Okay, but if we don't know, we can just try 2, we can try 4, and just keep dividing until we get it in lowest terms. Great stuff. So now we've done part I, we're going to do part 2 here, 2 I's. We have to find a decimal. So divide 24 by 64. We have to divide it to get a decimal. So what do we get when we divide? What are we going to get? Well, when we divide 24 by 64, we're going to get 0.375. So we've got our answer as a decimal. That's all we need to do, divide top by bottom. So I always think to myself, when I see that fraction symbol, it's basically telling me divide, because that's what a fraction symbol means, division. Okay, so we got our answer as a decimal. Now we got to get it as a percent. Now if we take the decimal we got, 0.375, we can find the percent. But what do we have to do to any decimal to get a percent? You have to multiply a decimal, divide it. If so, by what number? Okay, we go from a decimal to a percent by, we multiply a decimal by 100 to get to a percent. Here's an example. If we have 0.5, we know that if we multiply that by 100, we get that as 50%. 0.5 stands for 50%. If we go the opposite direction, divide percent by 100, we get a decimal. So 50% divided by 100 gives us 0.5. Okay, so in this question again, we're trying to go from a decimal to a percent. So we multiply this 0.375 times 100, we get 37.5%. So, based on what we just looked at, can you guys tell me what the correct order would be going from percent, or percent, fraction, and decimal? If you're going to put those 3 words in order, based on what we've done in this question, which would go first, which would go second, and which would go third? Give you a sec to think about that. Okay, first we went from a fraction, then we divided top by bottom to get the decimal. We multiplied this decimal by 100 to get the percent. So we go from fraction to decimal to percent. Good stuff. So, now we got a similar question, but it's a little bit different. We've got a fraction and it's got a decimal in it. And we've got to find the fraction in lowest terms. Now, a fraction in lowest terms can never have a decimal in it. So what are we going to do to get rid of that decimal? Well, what we're going to do is we're going to multiply both the 40 and the 12.5 by 2. That gives us 80 over 25. So now we've got a fraction that has no decimal in it. Now some people might have thought, well, if I've got a decimal, I want to multiply by 10. Because I know that'll get rid of the decimal. And you could do that and you get 400 over 125. The only thing is now you've got a bigger fraction, it's got bigger numbers in it. You're going to have to do more reducing to get the fraction in lowest terms. So the easiest way, for this fraction at least, is just to multiply it by 2. So 80 over 25 is not in lowest terms. So we need to find the largest number that divides into both 25 and 80, and that's going to be 5. So we're going to get 16 over 5. So now we've got our fraction in lowest terms. It doesn't have a decimal, and it's in lowest terms. Great. So now, this question here, we have percentage is in step 2 and decimal is step 3. But which one are we going to have to do first? Are we going to do the percentage first, or are we going to do the decimal? Remember, in the question we looked at originally, we went from fraction to decimal to percent. So we do decimal first and then percent. So we're actually going to do step 3 first and then step 2, even though they're listed differently. So first we're going to do the decimal, step 3. Remember, we got 16 over 5 in part 1. So what's that going to be as a decimal? I'll let you try to figure that out. Okay, when we divide 16 by 5, we should get 3.2. So we've got our decimal. Now we can do our percent. So what do we have to do again to 3.2 to get a percent? What do we do to any decimal to get a percent? We multiply a decimal by 100 to get a percent. 3.2 times 100 is 320%. All right, congrats guys. You've reached the end of the line, end of the recording. So again, I want to encourage you guys to practice all the questions on the recording. Make sure you can get them all. If you do that, I can pretty much guarantee you, you will do well on the test. So again, the test is on February the 22nd. And I encourage you guys to practice really hard. If you have questions with anything that's been on this recording, just let me know. I'd be glad to help. So guys, keep up the hard work you've been doing. Have an awesome day, and God bless. Bye for now.